Well, good morning, everyone. Welcome to the talk on moving from technical debt to technical health. My name is Declan Whelan. I'm an agile coach and developer. I think, but how many developers are in the room here? Oh, nice. Wow, nice. How many Scrum Masters, product owners, managers, executives? Cool. Okay, so we got. Well, I'm really happy to see a lot of technical folks because one of the things that I found, and I don't know if you found it, is that while Agile started out with a lot of focus on technical practices, some of those don't seem to be nearly as emphasized as they were 10 years ago. Has anyone noticed that? Yeah. And so you hear a lot of talk about technical debt, and sort of what I'm hoping to do in this talk is sort of shift the thinking from, oh, we got this big problem called technical debt, to how do we build technically healthy organizations where we're thinking positively about it. So, rather than thinking about, my health sucks or, I can't run, thinking about how do we get healthier. And I'm hoping you'll come away with some insights and hopefully some practical tips, tricks, things that you might be able to take back to your teams, or maybe even to your daily work. About halfway through, we're going to have a breakout exercise, which you'll do at your tables. And for the start, you get to listen to me drone on about technical debt and technical health. So I feel relatively qualified to talk about technical debt because I've written a ton of it. And so this isn't. This comes from firsthand experience, and even the code I wrote 3 weeks ago can look like technical debt today, and it's an interesting challenge. So I still like to code every day. I haven't coded yet today. So I do that. I'm with a group called Lean Into It, and we provide agile coaching. And I'm also a board member on the Agile Alliance, and sort of passionate about bringing greater agility to the world. And this talk was one that a friend of mine, Tom Grant, and I presented in Atlanta in the summer. And a lot of the material here I owe to Tom, and Tom's just a great guy. And when we prepared this talk, we had gone to Madrid to have a working session on technical health. I'm part of a technical debt. I'm part of a working group, and it was awesome. And Tom is an art aficionado, so he went to the Prada and got lots of great art to pepper through this talk. So we can thank Tom not only for the art, but for some great insights. So I miss Tom, but we'll move along without him. The art references, you'll have to ask Tom what they, if you're looking to follow up on the artist or the context. And he starts with this, and I'll start with this too, where technical debt is a temptation. I love the apple there. It's the temptation. This temptation of building something good, and the temptation of sort of cutting corners and taking shortcuts to get that something that's good. And I love that picture. To take the bite or not. And we talk about technical debt, sort of in the guise. Sorry, Raj. In the guise of software, it's sort of interesting that software really has no physical constraints. If you're designing a bridge or you're designing a house, you're going to put in those foundations first. You're going to build the walls. Like there's sort of a limitation of how you do things. So if you're building a bridge, you're limited by the tensile strength of steel or the temperature coefficients. There's all of these things that constrain how you build. In software, we really have no constraints. I mean, we could say CPU speed or storage or network speed, but fundamentally, essentially, we're unconstrained. We could decide to build a UI first and build a framework later. We could decide to start with the database. We can do things almost in any order. And that freedom is sort of empowering. It gives us a great deal of choice as we build our systems, and we can whip things out quickly. Often we don't have a lot of regulatory constraints like a doctor or a lawyer or a structural engineer might have. We do have some, but they're not nearly as kind of constraining as a lot of other professions. But with this kind of wonderful thing that we can do with software, which is really human creation, we have some challenges, and really it's so easy to cut corners. We can fly too close to the sun and plummet. And it's sort of seductive, right? We can always get that next feature out, cut some corners, and later on we can fix it up, right? And the problem is we rarely do, right? And that'll be a theme that comes back. And this point is really an interesting one. There's such a big thrust on innovation, and as we innovate quickly out of the starting gate, there comes a rising cost of that innovation as our technology ages, and sometimes it doesn't take long. We can just get slower and slower, and it's more difficult to innovate. So I think innovation is really a wonderful catchphrase, and I'm hoping that you see we need to build systems for innovation is really what this talk is about. Technically healthy systems are ones where innovation is not just at the start, but a sustained innovation. And I apologize, this projector seems to flicker a bit, and partly I pushed the wrong button a couple of times, so bear with me. And we eventually pay for our sins. And ooh, isn't she nasty? So I want to draw you a quick diagram. I want to see if this resonates with any of you. Imagine that we're building features over time. So we got features going up here. And we have our first release. We're greenfield. We totally crank this out, right? Like the number of features that we build over time is just this wonderful ramp of building feature after feature. We're just rocking it, right? And the interesting thing is that we're probably cutting some corners here, right, in pursuit of getting out these features. So when it comes time to V2, what's going to happen, right? We're probably going to go a little bit slower, right, because we've accumulated maybe a small bit of technical debt, right? We haven't refactored our code. We haven't put in automated tests. We maybe haven't been rigorous about our coding standards. Any number of things that lead to the code being a little bit messier than we would otherwise like. So when it comes time to build V2, our velocity, if you will, our number of features developed over time is probably going to drop, right? Fair enough? So V2 is going to sort of maybe look something like this, right? But the sad part about V2 is the management or people who are measuring how many features we're delivering will say, hey, wow, what's going on with you guys? You were rocking it. Like last year, you guys were totally rocking it. Now you're going so slow. Come on, come on. So there's even more pressure to achieve the number of features that you delivered over time with V1. But now there's increased pressure, right? But we've increased pressure to kind of match that, but we're sitting on top of technical debt. So what's going to happen? We're going to create some more technical debt in pursuit of trying to achieve what we did before. Are you with me? Make sense? So when V3 comes along, now we've got the accumulated technical debt from V1 and V2, and we start to look more like this. Yes? And you know where this is going, right? What happened? Then V4 looks like this. We just get slower and slower and slower. And sometime down here, we get to V5. And then normally around here is where you talk about the magic rewrite in the sky, right? Right? Where, oh, there's some like really cool new technology. There's some new architectural framework. There's there's a better way of building this, and there's this really new cool JavaScript library, and we talk about rewriting. And whether you choose to rewrite or not is a really important question. If you follow does anyone know the story of Netscape, how they basically went out of business by having a V4, which was first to market, had lots of technical debt. They made the decision to rewrite the whole thing, stop support on V4. 2 years later, Netscape was non-existent. So this rewrite is a very risky proposition. Has anyone gone through the rewrite? It's like exceedingly difficult to get right? Because there's so many edge cases that might be covered in the code that aren't immediately obvious when you start the rewrite. All of the knowledge that was gained in terms of fixing this bug and adding this is easily lost in the minutia of that, and you can end up taking a long time, and your competitors may beat you to market. I've seen it done successfully, but it's risky, right? It's also extremely expensive. So I'm just curious, if you think about where your system is right now, whether it's a project or your whole organization, whatever frame you choose, I want you to just take a few seconds and think about, are you at 1, 2, 3, 4, or 5? Let's count to 3. Just put your hand up with fingers for where you think your code is at right now. And then you can just look around the room, and I'm just interested to see. So some 1s, which is awesome. 5s, a few 4s, 7s, 2s. Really, what I'm hoping with technical health is that we're able to keep our production up here near V1 by really being intentional about, instead of just cranking out features, laying down a healthy technical set of practices and infrastructure to support sustained innovation and sustained value delivery is really what we need to start to move to. And by the way, I think Agile makes this worse. I see some nodding heads, because so many Agile transitions start with, oh, we're going to have Scrum Masters, we're going to have stories, we're going to have frequent releases, and we do all of these things which are like really important and valued, but we didn't think about the technical practices, right? And the technical practices that you need to produce sustained innovation and value delivery, I think are quite a bit different than traditional practices. And those are paid very little to almost no attention. And so in the pursuit of pushing teams harder and harder to deliver through rapid agile cycles, we end up actually exasperating this problem. So I think agility can make this worse. Because to some extent, we used to do a little bit of a lot more requirements up front and analysis and design. We might poo-poo on that, but on the other hand, there was some architectural integrity. There was a lot more thought was put in waterfall days to making sure that this was a good way to go. I'm not arguing for that. All I'm saying is that in an agile stance, that thinking and thought rarely gets injected into our work. It's just a relentless flow of features, right? So this is a huge trap, I think, for organizations today. I've seen. I was just last week. I was working with an organization, and they had 4 teams, and I was asking them how things were working, and 2 of the teams I ran lean coffee, so the topics were theirs to choose. 2 of the teams chose to talk about technical debt. One of the teams, I asked them, and these are actually really good questions that you might want to take back to your teams. How much of your capacity is spent, your development capacity is spent with new features versus bugs or helping support people or what have you? So I call that, in lean terms, that would be value demand versus failure demand. How much of your effort is spent in failure demand? So the first team I talked to said, we're about 50-50. So about half their capacity was absorbed fighting bugs and support requests. I said, okay, interesting. And how much of your capacity, when you are doing value work, do you feel is limited by the quality of your code? Like, imagine that the code was like beautifully designed, was everything that you thought the code could be, how much faster would you go? And they said, probably about twice as fast. So if we multiply those two numbers, really the latent capacity of that team is about 4 times what they're currently doing in terms of value delivery. But it was really interesting, then the next team I asked them that, and their numbers were even more startling. They said 20% of our effort is spent in new feature delivery, and 80% with bugs, support requests, et cetera. I said, wow. And how much faster do you think your code, how much faster could you be if your code was in good shape? And their answer was about 5x, different code bases, right? So they have like a 25x potential. Like, I don't think they're going to get near that, but they have a 25x potential improvement by improving the quality of their code, right? So people are, you know, if we want to get long-term value delivery, we really do need to take care of that. Has anyone else had that similar experience where it's just the whole capacity of the team is just absorbed with macheteing through the code and fighting bugs, right? So that's the temptation. We eventually pay for that, and that payment is extreme loss in value delivery to our customers and to our businesses. So I want to talk a little bit about what do we actually mean by technical debt, because it is, you know, it is a financial metaphor, and as any metaphor is, it has some strengths and it, of course, has some limitations. The original definition came from Ward Cunningham, and it came from, because he was working on a financial system, so he thought that a financial metaphor was a good one. But he makes some really interesting insights, like a little debt speeds development so long as it's paid back promptly with refactoring. And the danger occurs when it's not repaid. And entire organizations can be brought to a standstill under the debt load of an unfactored implementation, which is, I think, the numbers that I was just talking about reflect that end state. And does anyone know, you know who Ward Cunningham is? Yeah, he was a signatory on the Agile Manifesto and one of the 3 founders of extreme programming. So this is a guy who knows what he's talking about. He's the guy who invented the wiki. He wrote the first wiki. That was his idea. So this is a very thoughtful, smart guy. Textbook definition might say something like this. You know, it's a litany of shortcuts, bad coding practices, hacks, or, you know, in hindsight, we could have coded that more carefully. I love this from Brian Foote. There's this great paper called A Big Ball of Mud. A haphazardly structured, sprawling, sloppy duct tape and baling wire spaghetti code jungle. Has anyone worked in code like this? I have. I might have even written a bit of it. You know, and I think about, you know, what I do as a developer, and a lot of my time is spent dealing with code, right? So if we actually want to make a difference in people's lives, not just set aside the value proposition to our businesses, if you have to work like in code like that, that can be a soul-depleting exercise, right? And not only are people not happy, but they'll probably go somewhere else where they can be happier if they have to continue to work in code like this. I like to use this definition, which is like extraordinarily scientific, right? Stuff in the code that slows us down. As simple as that, right? And if you think about it, you know, you could, if you go back to my previous picture there, it's not hard to measure in a sense, right? Because if we look at a set of features that we built in V1 versus V2, this is our technical debt. We're spending this percentage of time doing value and this percentage of our time grappling with technical debt. And it sort of feels like this, woohoo, I'm cranking. And then a future you, oof, it takes so long to get anything done. So how does it come about? You know, usually it sounds like we don't have time to do it right. We got to get this feature out. We've made a commitment. We got to push this out the door. Come on, we'll fix it up later. It's not that bad. We don't really have time for code reviews. We don't have time to write the unit tests. We might have time to write them, but they take so long. We'll just ship it without running all those tests. We'll check in our code without running all those tests. And I love I don't know if you can see her, the programmer there. She's got a slew of Red Bulls, I think, there on her back. She's just ready to crank out code. Yeah. Awesome. And just to be clear, a lot of people can throw a bunch of stuff into technical debt, and I just want to be a little clear about what we're talking about. It's not necessarily quality or process debt or feature debt or user experience debt or skill debt. Like those things can actually contribute to technical debt because we get bugs and we hack out fixes to them, but they're not what I'm talking about technical debt. I'm talking about I'm in the code and I'm going slower because of what's in the code. Conversely, technical debt can also increase those things. So there's certainly a connection between all of those, but I'm just talking about the stuff that's in the code. What is the impact? I love this. The monkey, or the donkey on his back. That's what it feels like at times. It just gets really hard to work in it, right? It's hard to add new value. We get bugs and it's really hard to, you're spending time looking at gigabyte log files, searching through them in the debugger, poking away, hoping you can find the bug. It's really hard to reproduce. It just gets tiring after a while, and maybe that company X is doing some greenfield work where I could go introduce my technical debt over there or something. As a developer, we spend probably 60 to 70% of our time looking at code, let alone writing it. So we spend way more time reading it. So that technical debt really slows down our ability to understand the minutiae of the code, but overall how the code works in itself. And if you're reading reams of run-on sentences and incoherent prose day in, day out, it can get really, really tiring and draining. In fact, I actually sort of love actually fixing up legacy code. I don't know if anyone else does. Like, I get such joy out of making what used to be crappy code better. But where I despair is when I don't have the ability to do that, where I feel like I can't because we have these commitments or there's not insufficient support within the organization for me to do that. So technical debt's actually sort of fun to fix as long as you can do it. What really sucks is if you can't do anything about it. What you notice on the team is like really inconsistent velocity, possibly getting slower over time, as that feature graph over there showed. There's less flow, lower team morale, and eventually, it's time for the rewrite. Or, I've been in organizations where the CEOs pulled me aside and said, I just want to fire my whole software team because they suck. And and it's not that, that's what they thought. That was not the case at all, but it's just that the technical debt got so bad that when you look at it from the outside, all you see is the output, and it can be difficult to get behind your people when every release has multiple bugs, and it takes them forever to roll out the point releases to fix them. And overall, it gets really difficult to coordinate sales and other parts of your portfolio and marketing with those things because you can't count on consistent value delivery. Usually it shows up as people pointing fingers, and it gets really, the same organization I was at, there was one developer there who was it was on the team that was basically running at 4% of their potential value delivery. And he was the one who said, we really need to clean up this code. And his approach was he would go away for a while and try to clean up some code. He didn't really have authority or support to do so. And he was seen as being this perfectionist. He was sort of outlawed within the organization. Oh yeah, go and talk to him. He's like all this about technical debt stuff, right? So the culture of the organization was he was ostracized for really caring about the long-term value delivery. I felt so badly for this guy. And sort of my hope is I'm able to help the organization see it is about value delivery, but it's about value delivery over a longer horizon. You know, with Scrum and 2-week iterations or whatever your iterations length is, there's a tendency to just look at that short-term value delivery. But if we extend the horizon over like months or years even, you know, what you really want to do is optimize for long-term value delivery, and that's what he was doing. So I'm hoping getting alignment around, hey, we all want the same thing. We want value delivery. It's just our time horizons are different, and let's come together around having the same horizons. It's really hard to control this technical debt. You know, the relentless pressure. We just got to get it out, especially if you're, you know, and I think things like lean. Does anyone who here is in a startup? Couple? Yeah, ish. You know, and I was in a startup with Nick, and we had on our board of advisors Eric Ries, who was the writer of Lean Startup, and we didn't get to. I only had one conversation with Eric, but Lean Startup and this drive to kind of continually push out features, especially in Lean Startup, is really a great thing. We don't overthink things, but if it's not done with responsibility, it can immediately add technical debt to your code. And I'm going to say I wrote a ton of technical debt there, and Nick did his best to clean up after me, but I don't know if he quite achieved it. I don't know. And it gets out of control quickly. It does not take long. Like literally within weeks or months, you can see the impact. And that's so weird. I've seen this where people maybe don't really know what they're doing, and they could be young, but they don't need to be. I've found some of the technical debt builders to be some of the more senior people on teams, and conversely, I found some younger people to be surprisingly adept at it. So I was recently working with another team where they had a woman who was awesome. She was like 6 months in BitMaker labs, and she totally got it. She was like, she got it. So it's not necessarily an experiencing, it may be as much of a mindset thing, but it's really an awareness around what writing code well for malleability, for future change. And this is probably the biggest thing that I notice is that it's really hard for non-technical folks to get it, right? And this is sort of, as a technologist, this is sort of our challenge. And I think of it like this. Imagine you were to go to a kitchen, you're to go get a meal, and you order the meal, you get a nice meal, and then you just decide to, maybe on your way to the washroom, I'll just go peek in the kitchen, and you poke open the door, and you look in, and you see grease on the floor. You think you saw a mouse scurrying in the corner, fluorescent lights flickering, dishes, dirty dishes piled up everywhere. You pretty well know that this restaurant's not going to last very long, right? Sooner or later, somebody's going to, a health organization's going to come in, or someone's going to get sick, they're going to get shut down. Like, this is not a healthy kitchen. That's what's going on in our code, but it's hard for anyone. Any one of us can go in a kitchen and see that, but if you haven't worked in code, it's hard to open up and look at the code and know, oh, that's really horrible code or not, right? So we have this visibility problem that makes it really difficult for our for managers and executives to feel what it's like to work in that code. Now, I had some teenage boys, and they would go make has anyone had this? They go make a meal, and you go in the kitchen afterwards, and you go, oh, geez, I got to like wipe down the counters, put the dirty dishes away, put all the boxes that they laid out, like all that cleanup work. That's sort of what it's like working in crappy code, where you're constantly feeling like you got to clean stuff up just to get something done. And the metaphor of this like crappy kitchen is appropriate. Or another one that I'll sometimes use with executives is, think about, you're building an assembly line. How much effort are you spending into keeping that assembly line in tip-top shape? What is the system by which we're building future value? You know, are you investing in constant maintenance of these systems, swapping in and out new systems as they become old, replacing the belts, whatever it might be to keep these systems in tip-top shape? I don't see much investment in that. It's usually just next feature, next feature, next feature. And it's like the golden goose, right? We just keep squeezing that golden goose and get more golden eggs out of it. And then often it's, you know, blame is probably one of the worst things, and then the developers are sort of held to account for that. And they are, after all, the ones who wrote the code. And we're going to dig a bit more into that. So, does anyone's code feel like this? I've worked in code like this. This is sometimes what it feels like, to be honest. It's just a mess, right? And a lot of times, you know, it's not mess that you made. It's mess that you inherited. You got thrown on a project, and this is what you got, right? And developers are often criticized, and maybe rightly so, that, you know, everyone's code looks like crap compared to my code, right? Which is sort of human nature. But the fact of the matter is, a lot of the code is really horrible out there. I don't think I've gone into an organization yet, except perhaps startups, where they say their code is really good. That's why I was really happy to see some 1s and 2s here, which is great. But has anyone worked on I'm just curious, has anyone worked on working in code that's more than a few years old, that's below at a 1 or a 2 level? Is anyone doing that? Has anyone had that experience? And just curious, are you using, what practices make that work for you?
DDD, regular refactoring, very slowly XP practices.
So extreme programming practices.
Yeah.
Yeah, cool. And we'll get to that. Yeah. So you're basically investing in keeping the assembly line and keeping the assembly line running and keeping the kitchen clean. Yeah. It's possible. We know how to do it. Like, this is a solved problem. We know exactly how to do this. We just have to have the wherewithal to do it. So what can we do? So I want to do a little exercise called Dice of Debt game. I'm going to borrow yours. So in front of you, and actually, if I could get your attention just before you open up, because it'll get chaotic here real soon. You're going to get a few sheets in your envelopes, and there's 2 per table, so you want to split up into groups of 3 or 4. And we're going to play a little game that's around technical debt. And the way it's going to work is you're going to get a bag of dice, and there's the colors aren't important, but you'll get 8 value dice and 4 technical debt dice. And basically what happens is every sprint, there's going to be 10 sprints, you're going to roll the value dice and score it. There'll be a spot to put it up there. And then you're going to roll the technical debt dice and put the number there. These rules, there's a rules in front of you can refer to. And then you take the difference. And then you're just going to, basically your technical debt is subtracting from your value creation. Does that make sense? And then you're just going to sum over time and see how, how much value you can deliver over 10 sprints. But you have some choices that you can make. You can make some investments. So there are 4 of them, and each one of them has a cost. So for example, the first one will be reduced complexity. So you can focus on basically refactoring the code. And that's going to cost you 2 dice for 3 turns. So you take 2 of the value dices and set them aside for 3 turns. You're not allowed to play them because basically that represents the investment you're making in reducing the complexity of the code. So you can choose to make that investment, and there's an upside is after you've done that, for the rest of the game, you can remove 2 of the technical dice. So instead of having 4 technical dice, now you just have 2 technical dice that are subtracting from your delivered value. So you have to keep track of, so in there you'd put basically an X saying that you've invested for 3 turns in that. So far, so good? The only other constraint is that you can only do 1 of those at a time. So you have to pick, and you don't have to do any of them if you don't want, but if you are going to invest in technical debt, you can only do 1 at a time. And there's the summations are down here. And if you have any questions, I will be around. And the other thing that you may want to graph is on each turn, you just graph what your sort of net score was on this chart. And then we'll have a little healthy competition to see who can get to the highest total value over time. So just at your table, I'd like you to think about like what strategy you used for technical debt, and was that similar to the strategies that you've used in your real day-to-day work? And if it is, sort of cool. I suspect like there are more than 4 ways to reduce technical debt. This is just a smattering of things you could do. Maybe you're doing other things. But what are the things that you're doing at your table? Maybe you could discuss. And what are the obstacles to actually doing some of these practices in your work? So think at your table, like, what are you doing? Is it similar to the game? And if not, like, what are you doing and why? What's standing in your way from doing this? Because I hope you mostly saw that we would have increased value if we actually invested in some reducing our technical debt. So I'll give you 5 minutes to discuss as a table. I hope you found that game sort of fun. So you can, if you Google Dice of Debt Game, you can download all the materials except the dice. They don't download so well. And you can play this on your teams or with your organizations. It's all freely available. I would ask at the end if you could leave your scoring sheets. Tom, who invented the game, is actually collecting all the scores and sort of accumulating what strategies teams use and what the net results are. So there's actually if you go to his web, if you go find it, you'll actually see sort of the cumulative sort of average scores, etc. I hope you had. I'm not going to debrief the whole room here, but I hope you had some good discussions about technical debt in your team and your organization. And I sort of want to move on. And has anyone heard of modern agile? From Joshua Kirovetsky? A couple of people have. So, sorry, how long have we got?
60.
Pardon me?
60.
60?
You're
at the 60, thank you. So modern agile looks like this, and this is really worth paying attention to because it's really, I think of it as a recasting of the Agile Manifesto and what was important now into kind of a more modern way of thinking about it. Let's make people awesome, including our developers, including our testers, including everyone. We often think about making our customers awesome, which is great, but we need to make everyone awesome. We need to focus to delivering value continuously. So when we have bugs that impede that value flow, or technical debt, as we saw over here, slowing us down, then our ability to deliver value continuously diminishes over time. Experiment and learn rapidly. So we might try some experiments. What if we introduced unit testing for a few sprints? What would that do? And view those all as experiments, not like this is our new way of doing it, but here's something we can try and reflect on it as a team. Was that actually helpful or not? And if it wasn't helpful, is it because we missed some elements? Is it still worth trying and we just need to change the way we approach it? Or is this really not something that would work for us? And viewing things as experimentation and learning loops. And finally, this one is like the one that is sort of the least obvious, I would think, is making safety a prerequisite. I was reading this morning, I was looking for good stories about technical debt and where people made big mistakes. And usually it's, you know, a lack of control around some bug got into production. And you know, there was a case of somebody losing $500 million, is like something ridiculous. It was $120,000 a second because of a bug that got into production. Right? Or the Netscape case. So is it safe for us to release this code? And how do we know it's safe? And the only way I know how to build that safety, or the best way I know how to build it, is to put in automated tests. And making it safe, making it difficult for people to push code into production that has bugs. So making it safe to work on the code. I think a lot of reasons why people don't deal with technical debt is because they say, and you've probably been there if you're a developer, oh, don't touch that code. There's dragons under that code, right? You just don't touch that code, right? As soon as we get into that spot, then that code ripples out and grows. And after a while, it's like really unsafe to touch any of the code. So people start to hack around the code that they don't want to touch because it's too risky to touch. So we need to build safety into the way that we work so it's safe to change code. We need to be able to fix the bad code, and it's got to be safe to do so. And it's got to be safe for people to talk up and advocate for that. In the case I was talking about before, the person was sort of ostracized for speaking up about taking care of technical debt. So it's got to be safe for people to voice their opinions and stand up. So the other thing I want to introduce you to is the John Boyd has the OODA loop. Has anyone heard of the OODA loop? Yeah, cool. So it was originally from, I'm blocking your spot there, is from John Boyd talking about fighter pilots, basically, and how fighter pilots are able to be successful. And it turns out that he noticed that there was this loop where people observe, what are all my inputs? What do I make sense of that through an orientation step? And then I decide to do something, and then I act. And you keep going through that loop. I think as long as there's a loop, I think it's good, right? So, you know, plan, do, check, act from is a part of Lean, or plan, do, sense, act, which is sort of the more one I hear more often. In any event, being intentional about what's going on and continually building feedback loops is the key here. So I want to frame how we might improve technical debt using the OODA loop. If you chose to use another loop, that's cool. So the first thing is observe is you can't manage what you don't measure. Maybe that's an oft overquoted term, but start to measure it. And there are some good tools out there. This is SonarQube and Squale. You can get some technical debt metrics, and this is surprisingly easy in most cases to wire up and go analyze your code. Depending on your language, your tools may differ, but there's lots of good tools out there to do this measurement. Things like cyclomatic complexity, duplicated code, sizes of methods and classes, these are all things that most of the static code analysis tools will do for you. You could look at some aggregate things like how is our velocity changing over time. Of course, I'm always very careful about using velocity as a metric in case it's used to judge teams, but this might be more of an internal to the team. Is our velocity actually increasing or decreasing, assuming that we're not going to count points for defects? One I love is team happiness. Is that a question?
Yeah, I was wondering
Good point. So the question is like, should you measure velocity over time or like some trend?
Yeah.
Yeah, I would say for all the metrics, to me, they're all trends. So thank you for bringing that up. Like, an absolute number is rarely important. What's more important in almost all cases is that trending in the way that we intend. So I'm very happy to have like cyclochromatic complexity be kind of maybe a horrible number to start, but is it actually getting better over time? That's really the important point. Because there's no real, I've seen teams get slaves to these goals. I saw one team where they started to bake these rules into their check-in protocol, basically their post check-in hooks, and you couldn't check in if the cyclomatic complexity of a method was over 10. And they had this situation where the code really required it, but it was so locked in that they couldn't do it. So they actually they intentionally wrote poorer code in this one case just to squeeze it by this kind of automatic constraint that was put into their system. So I'd be wary of any absolute metric, and they're always just guides, right? They're always just guides to action. They shouldn't be used as gates that you got to go through. One that I really like is team happiness. How happy are you working in the code? Because the cool part is that's a really easy thing to measure, right? You could just go away now and say, how happy are you working in the code? And you would be, and if there's a difference, that's really interesting. If everyone is the same, that's interesting too. But have that measure, and you might even want to have a retrospective around what is our team happiness. That's such a simple thing to do. So you can get all the sophisticated tools in the world, but more important thing is how awesome do you feel working in this code? If we were to tie it to modern agile. The one that I like is this one too: percentage of capacity lost to technical debt. So how much faster do you think you could go if there was zero technical debt? Now, it's a hypothetical question, but once you ask that question, let's say it's twice as fast, you've automatically got an economic argument, right? Oh, what's our burn rate per person? We're losing X dollars per year to technical debt. You immediately have a number that you can start to make a case for, right? And in the case that I was talking about, where there was potentially somewhere between a 10x and a 25x improvement, that's pretty huge, especially when most people think about building capacity as hiring more developers. But what if you could get more capacity out of your existing system by taking care of it? That's a lot easier to do than hire good developers. So you can make an economic argument if you start to measure capacity loss to technical debt. I haven't used Squale a lot, but this is a tool that's built into SonarQube where you can actually visualize the technical debt and use different dimensions such as the size. And the one thing I like about this is that there is a cost to not fixing it, which is the non-remediation cost. I won't go into it, but basically there's a cost to fix it. But really there's a cost to not fixing it, which is often not understood, right? If we don't fix it, here's how much it's costing us, and Squale is one tool that will attempt to give you a measure of that. Again, I wouldn't take it verbatim, it's just a measure that I have to guide action. This is a book I read recently, and I really like it. It's Your Code is a Crime Scene. Has anyone read this book? Yeah, it's really cool because it's really taking, and it's not saying your code is a crime scene. It's more like applying forensic analysis to code. What's cool about this is there's lots of great scripts that will analyze your code and say compare it with the churn. Because one of the important parts about technical debt is, if you have a code module that you haven't touched for 3 years and it's ripe with all of these cyclomatic complexity or duplicate code, but you're not touching it, then it's not hurting you, so it's not really technical debt. So what you really want to do is focus on which is the code that we changed yesterday, and focus on that. So there are some really great ideas, and actually and all of the code in here is Python open source code. You can download it and run it against your code, and it will do things like compare where do we have the worst offenders from technical debt, or our static measures tell us this is the worst code, and where's the code that we're actually touching on a day in, day out basis by looking at our repository check-ins, and then combine those to say, here's where we should focus based on how much that code churns and how bad it is. So you can start to focus on the technical debt that's hurting you the most. Awesome book. And this is from Henrik Nyberg saying, why don't we just have on our teams a working agreement that says, why don't we just stop writing crap code? And Henrik has this wonderful way of saying it. He says, we realize now we've been writing crappy code. We're sorry about that. We're going to stop now. There's sort of a great humility in that, right? But it's also owning up. So if we stop writing crappy code, we will be able to have a more sustained velocity. And sort of his message is that this can be a team decision in a working agreement that we should just stop writing crappy code. Or, as well, start to clean up old crappy code. More or less the same thing. And if we can clean up the old crap, then our velocity might even go up as we fix the bad code that we've inherited. I sort of have a mixed feeling about this message, because to me, it sort of is true. I mean, who writes the crappy code? It's us as developers, because we've typed it in, right? So this is sort of an appeal to professionalism, and we should just stop typing in crappy code. But I feel like, and I don't know if your feeling is similar, that if that were true, I've met many, many very talented, thoughtful, careful developers. I think that far exceeds the amount of technical debt that I see. In other words, I think there must be bigger forces at play, because I meet so many talented people. If people all did this, then why is generally our code in such crappy shape as an industry? So my personal feeling is, yes, we can certainly have the developers take this stance, but I feel like there's more to it than just this. And I'm going to go there in a few minutes. And there's certain things you can do, like have a definition of done that includes code reviews, or automated test coverage. And probably the biggest thing that I like to suggest comes from Robert Martin, is just follow the Boy Scout rule. Just as a rule, keep the code cleaner than when you left it. Keep your campground cleaner than when you got there. Keep your code cleaner than when you got there. And it doesn't have to be much. It could be fix the indentation, fix some misleading comment, or better, delete it, or change a parameter name. Something could be like very small things that just make the campground, the code, just a little bit cleaner than when you got in. And the beauty of that is that if we apply that with rigor and intention, then we will always be changing the code that changes the most. And so, code that changed yesterday is more likely to be the code that's going to change tomorrow. So if we apply the Boy Scout rule, we're likely going to get the biggest bang for a buck just automatically in improving the code. And the trick is to be able to apply the Boy Scout rule safely, right? Which is where tests may come in. But there are a lot of code refactorings that you can do that are safe. So if you have a good IDE, or you're willing to learn how to refactor code safely through manual steps, you can actually improve the code a lot, even in the absence of automated tests, given the right language and IDE to support that. So there are ways that you can do this. Basically, we can include technical debt as part of the planning at the portfolio or the project level. I've seen teams I worked with one team that had a rule which worked for them. I wouldn't say it would work for every team, is every 6th iteration was a technical debt iteration. Right? I don't think that's a good idea, because I think that worked for them, and you may want to try that. I think that applying the Boy Scout rule and applying a little bit of rigor to every day's worth of work is a healthier approach. But this can be one way to start to get at least get some intentional action around removing technical debt. We've worked at, I'm on this Agile Alliance technical debt group, and we've built a model called the A2DAM model, Agile Alliance debt analysis model, where we've looked at various, tried to come up with some rules about code, and there are several of them. We're working with vendors now to put these into their tools, but basically there's some for each metric, there is some rationale and some remediation that you can apply to fix the code. So it's an interesting model to go take a look at. Some of the people on this team were, I would say, experts in metrics. I'm not, but it was fun to listen to them argue over how many lines of code in a method is appropriate. They were always way bigger than me. I don't know what that said. I'm just always, I'm just curious, for the developers in the room, how many lines of code are in a method before you start to go, that might be a bit big? Just yell it out. 7? 15? 20? Yeah. So I'm always sort of surprised. Some organizations I go to, it's like 20, 50, 100 sometimes. And sort of my number is around the 5 mark. Most of the methods that I write and encourage people to write are like 1 to 3 lines of code. So they're, 5 or 7 doesn't bother me at all. That might be appropriate, even 10 or 15 in cases. But, we were not taught to code that way. We were taught a screenful was about right? Which was, let's say, 24 lines, which now I think is seen to be like way big. So there's a lot of unlearning that developers may need to have to sort of really take care of technical debt. Start automating stuff. I actually found that photo myself. Tom found most of them, but we need to free up time from doing the mundane to really focusing on making improvements. So automating tests, automating scripts, automating, the DevOps cycle is really putting automation on steroids, but that whole idea of just automating the mundane so that people can really focus their intelligence on the tougher problems. I'm always amazed at, in the organization I mentioned, they were so caught up in dealing with automated tests, manual tests, that they were more or less ground to a halt because they just spent their entire, 3 weeks, 1 week was spent doing regression testing where they had a code freeze because they had no automation in place. And then the developers were scrambling. Of course, the code freeze was never truly a code freeze. It was broken all the time. But we need to start automating. And this is really what I think of as the lost art, which is extreme programming. And to some degrees, this is the set of practices from extreme programming. And this is where I started my Agile journey, was with this. And I think a lot of us that have been doing Agile for a while were here. And test-driven development, refactoring, simple design, and pair programming, the ones at the core there, those are key. Those are absolutely key. That's the only way that I know how to really take care of technical debt. And yet I rarely see these practices introduced to new Agile teams or even experienced Agile teams. This is what we need to be able to do to really work on reducing technical debt. Or should I say improving technical health. And I would add mob programming, extending the pair programming to mob programming, which is just a wonderful way to iterate and learn rapidly through learning as a team. So if you have someone who's really good on your team, code the whole team together so that thinking and practice gets learned by everyone at the same time. Nothing is more frustrating than being the developer that writes all the good unit tests. I don't know if anyone's been in that road. So you're writing all the unit tests, but you're the only one, right? And then you might be the most skilled developer in the team, and then you're writing all the unit tests, and other people are checking in code, and it breaks the test. So now you're going to fix their tests, and you end up in this where your most skilled developers are applying these practices, but if the whole team isn't, that person's going to get swamped just trying to keep all the other code up to speed. So it's really important to work as a team, and mob programming is, if you haven't heard about mob programming, it's definitely worth checking out, and it sounds surprisingly inefficient, except it isn't, at least in some cases. And I want to end sort of by talking about systems thinking, and this is a quote from Deming. 90% of the problems belong to the system. He didn't actually fill in the. There was a precursor. I should have put ... But 90% of the challenges we see live with the system. I don't think developers write, I don't know any developer that wakes up in the morning and goes, you know what? Today I'm going to write some really good technical debt. I'm just going to write the crappiest possible code I can. That's not what happens, right? There are systemic reasons why they write that crappy code or don't fix it. And that's the 6%, right? And I want to just end with a few ways of viewing the system. So here's sort of the what I've noticed happens, right? This is a systems thinking diagram. So let's say we have some change and we have a choice. We can do the quick fix, or we can do the fundamental fix, which is like doing the right change. And the right change is going to introduce some delay. So we have a choice to make. Are we going to hack it, or are we going to sort of like do it well? And here's the dangerous thing that happens in code, is if we decide to do the quick fix, that means the next time we go to change that code, we're more likely to do the quick fix again, because it's already sort of yucky, right? And it gets harder to do the fundamental fix because there's been this hack on top of the code. And over time, you see this, where we tend to do the quick fix more and more frequently till finally, a couple years down the road, we don't even think about it. Everything is just a quick fix that's leading to technical debt. So this is a dangerous systems loop that we need to intercept, right? So it's either like decreasing the delay, or what can we do in our system to increase the chances that we're going to make a fundamental fix over a hack? And this is where you can see where agile, without attention to technical practices, will lead us more than likely into quick fix decisions more often than not. And those quick fixes are going to increase the chance that you're going to make the same decision down the road. A very dangerous loop that we need to jump out at and say, like, what can we do to make it more likely that we will choose a fundamental fix over a quick fix, or any fundamental change over a hack. So we just have a few minutes. Actually, I don't know if we quite have enough time for this, but I'm just throw some things out here that I've been thinking about that lead to. I was going to have you do this exercise, but instead you get to listen to me for a few minutes. Hiring practices, when we hire, do we actually hire people that have those engineering skills that we're looking for? Might be a good idea, right? Outsourcing, outsourcing may be appropriate, but if we outsource, we actually making sure that those people are building using test-driven development. Do they have refactoring skills? Do they have coding standards? Like, are they actually doing the engineering the way that we want it, or are we just sort of tossing the code over them and hoping it comes back clean, right? Most of the time, it doesn't, because they just feel the pressure to deliver on their contract. Staffing up for projects might be the worst one I see. Oh, we got a project, we'll spin up some people, we'll throw them in it, and now they're new people. Maybe none of them have worked in that code before, and now they're doing their best, but they just don't understand that code. So they have A, their other element, and B, when the project comes in, they're incentivized to finish the project, right? So their horizon is 3 months, 6 months down the road. And especially if they're on contract, they know they're out of there. So their incentive is really around trying to do the best job they can to get the features out so that they can fulfill their SOW. But if they have no incentive or no motivation for the long-term health of the product, why would they? You know? If they actually start to slow down in favor of putting in automated tests and somehow that impacts delivery or perceived to be, they're in trouble. And now, if you know, A, they might get fired. B, they probably got, at a minimum, got a fight at their hands. And if you're a single mom who's a coder, are you going to take the risk that are you going to do that? Or are you just going to say, okay, I'm here to code this stuff. I'm just going to code it, hit the deadline, and I'm good, right? I know what I would probably do, right? So these forces, I think, are the 93% that Stephen Deming talked about, right? That they're not that coders set out to write bad code. These are systemic problems that I'm just starting to explore now, but I think we really need to take care of this. I think our industry has been remiss in taking care of truly building valuable systems. And our responsibilities as leaders and managers is to build systems that allow us to build valuable work and not just crank out new features, right? This is really a call to action for anybody who's working on systems to build systems that actually make building high quality code and sustained value delivery inevitable. And it's a challenge, and we already heard that a couple of people are already there where they've worked for years and years and they're still cranking out features. We can learn from them. So here's a few things to think about in your organizations. If you think about the OODA loop, what measures could you make? Could you measure the technical debt? There are tools out there that do it. I would really encourage you just to measure what's your happiness working in the code and how much do you feel you're slowed down by technical debt. Those are so simple measures, you could do them tomorrow. And how can you make that information relevant? Like, what is the bottom line impact to our organization when we factor those things in? Try to orient the teams and the organizations to this problem, and what might be some options to deal with it. And then we can kind of move to decisions. How could we make some decisions to start to impact this now? And these don't have to be big ones. Let's try writing some automated tests next sprint. Let's just write one. It's a good start, right? I've worked on a code base that had 0 automated tests, and I just said, well, let's just write one next week. Okay, let's write 2 the week after. And after 18 months, we had like 90% code coverage in the code. So it's just a matter of starting and taking small steps. And if you apply that idea of focusing your energy in the code that changes the most, you'll actually get some pretty early results from that approach. And then act. What could you actually do in the next 2 weeks? We got some options and just do it. We as an industry need to step up, see that agile to some extent is a threat to value, and start to build in value in the way that we fund, staff, and act in a day-to-day manner. And I'll end by saying this year, I'm not a person that ever sets up yearly goals. This year, my goal was to do something in the world about technical debt, and I've probably trained 200 or 300 engineers in some of the practices that I've mentioned here this year. So it's just a small thing, and I participated in this working group looking at technical debt, and I'm looking for every opportunity to speak at conferences to get people thinking about this, because we can do so much better, and I think we will. And I want to thank you for taking time to come in here. It's been a pleasure.